So this article is related to comparative analysis of ODE solving methods for the quadric model simulation using the MATLAB basically. Okay. In this model, I have used the Runge-Kutta method. In terms of RK4, we called it RK4th order method. So just a second, let me just explain how it works. So in the suspension systems for the dynamic modeling using the Heun method and Euler method, midpoint method, and the initial conditions for used in the detailed mathematical formulation in the quadric model, which is developed in the MATLAB. So I have written its abstract, like how we can just develop the complete quadric model with the comparison of different uh, methods. Okay, different scientist methods. In terms of, we called it Euler method, midpoint method, Runge-Kutta method, which is called it RK4 method, and Heun method. Okay. So next is introduction, like how we can use the piezoelectric sensors for the positive terminal and negative terminals. In terms of the quadric system, to check it's the sprung actuator and unsprung masses. Okay, so these are the quadric mass suspension system in terms of different distances. Then importance of vehicle dynamics. In this section, I have just added how we can drive and how we can add the complete its complete vehicle dynamics with the vehicle stability. Vehicle stability, and that vehicle stability directly links with the sprung method and the unsprung method of the vehicle optimization dynamics of different manufacturers, which uses that are not only safer and more efficient but also more enjoyable to drive. So here is a problem statement, like I have just developed a complete quadric suspension system, use some numerical methods according to Euler midpoint, Runge-Kutta fourth order, and Heun method to simulate its dynamic behavior. And I have also compared its accuracy with the efficiency. Okay, so these are the mathematical modeling of quadric model parameters according to sprung, unsprung, suspension stiffness, tire stiffness, suspension damping coefficient, and the damping ratio basically. Okay, so all the values and the equations are added here. These are the steady state representation in called we called it in different methods. So we have explained how Euler method is developed according to ordinary differential equations. ODE means ordinary differential equations. Okay. So next one is midpoint method, and next one is Runge-Kutta method, fourth order method, and next one is the Heun method. Okay. All the equations with its methodology are added here. So in MATLAB times, we called it Euler method. In Euler method, we just develop its suspension with the wheel displacement method. Next one is midpoint method. We are just checking its the accuracy in terms of steady state stability of different methods. Okay, so Next one is Runge-Kutta method, fourth order method. Next one is Heun method. Then conclusion and future work also added in terms of safety, handling, comfortable and different performance behavior of the efficient and advanced vehicle systems. Okay, so let me just also show you. Yes, basically let me just, okay, we need to just shift on here all the equations. Yes, these are the functions used in our section. Yes, this is also a function. Yes, ODE Heun method also use a function, ODE midpoint method and ODE Runge-Kutta fourth order method. So we need to just run this section, which is basically, we called it clear all and close all to check output results. Okay, let me just run it. We will get the output results according to different methods. It is taking some time, but we will get the output results soon. Okay, see, these are the output results for different methods developed in the MATLAB. Okay, Euler method, midpoint method, basically Heun method, and the called Runge-Kutta fourth order method. Let me just explain, like Runge-Kutta fourth order method in C. This red line represents the suspension of the vehicle. Okay, and this blue dotted line represents the wheel. So the suspension and the wheel having a more difference in the Runge-Kutta method. But in the Euler method, it is little bit low. Okay, so it is almost good method, and the Heun method also having a low difference, and we called it Heun method. Yes, just a second. Euler method and the midpoint method. Yes, I think yes. Basically, the one of the most stable method is the Euler method, because the Euler method is provide us the more stability in terms of wheel suspension during the running of the car. Okay, so these are the complete MATLAB output results. If you need to ask anything, you just call me. Okay, I will answer your questions. Thank you.